So everything in math either is exactly what it sounds like, or it's named after the person that came up with it. So the rule we're going to do today is called L'Hopital's rule. So he's the one that came up with this rule. It is a rule for limits, but I can't teach it until after you've learned your derivative rules, and you'll see why when we go through this. We have talked about one indeterminate form already. Does anyone remember this? Usually if I wait long enough, someone comes up with it. What means indeterminate? Think back to unit 1 with limits. Like, what result did we get that we called indeterminate? Oh, when there's a hole, but what does it come out to? When there's a hole in the graph, what do you end up with, like, as your result? Like, for example, hey guys, if we try to plug 1 into this, it's 0 over 0. Okay, so your indeterminate form is 0 over 0. That means that there's a hole. Go ahead and close the Chromebook. Now, I know, usually if I wait long enough or I like pull it out, because I don't want to just say this is this and that is that. I want it to be more like a conversation. The other indeterminate form we're going to look at is infinity over infinity. There are a multitude of other indeterminate forms, though, like 0 to the 0 power and infinity to the infinity power and infinity to the 0 power and infinity times infinity. And if you want to look at those, there's this cool thing called the internet, and you can Google them. We're going to look at just these two, but there's a lot of wacky stuff that can happen. All right, so L'Hopital's rule says if f and g are differentiable, and the reason they have to be differentiable is because we're going to take the derivatives, spoiler alert. All right, so if the functions are differentiable and you get one of these indeterminate forms, like it comes out to 0 over 0 or infinity over infinity, then this is the rule. Limit as x goes to c, and again, c would be some number, so like limit as x goes to 1 or limit as x goes to 3 or, you know, whatever it is, of f of x over g of x. If you get 0 over 0 or infinity over infinity, that equals limit as x goes to c of f prime over g prime. And what you have to remember is it's not a quotient rule. You do the derivatives separately, which is good because that's easier. All right. Now, this does usually show up on the free response part. So for question 1, I'm going to write down every last little piece of information and all the justifications that you would need to put if it was free response. After that, we'll pretend it's like multiple choice where you don't have to write all that. You can kind of just like do the problem. Okay. The first thing that you have to state is that the functions are differentiable. So when you look at the numerator, that is squared. That's a parabola. That's differentiable. Denominator is also differentiable. So we're going to say x squared minus 4x plus 3 and x squared plus 3x minus 4 are differentiable. You have to say that. And on the AP exam, please write out the word differentiable. I'm not sure if they'll take diff as an abbreviation. I will. That's fine. But write it out on the AP. So you have to state that. If they're not differentiable, you can't take derivatives, and then the whole theorem goes out the window. Now, you are not allowed to write that something equals 0 over 0 or that something equals infinity over infinity. That's what's called a linkage error, because 0 over 0 is not a number and infinity over infinity is not a number. So you can't say that something equals them. So what you have to do is show them separately. So we're going to do, okay, limit as x goes to 1 of just the numerator. And then we're going to do limit as x goes to 1 of just the denominator. So you have to do them separately, because if you do it together, it's going to equal 0 over 0, and you're not allowed to say that. You can't link those together. It's a linkage error. But if you plug in 1 to this, what are you going to get?
No, I'm stupid. I forgot what 4 times 1 is.
It's 0, guys. All right. And if you plug 1 into this, what do you get? 0. Okay. So very good. We successfully showed that it comes out to 0 over 0 without writing equals 0 over 0. That's the workaround. Do you get what why I did that? I know, I'm the messenger. I think it's kind of foolish too. I think you should be able to just do the problem, but on the AP exam, you're gonna have to write all this. All right. Then you want to link these together and you do want an equal sign between those. So we're gonna say limit as x goes to 1 of all of this. And you're probably like, Ms. Cole, you're just recopying the problem. Yep. You have to say that that equals limit as x goes to 1, and then we're going to take the derivatives. The reason why taking the derivatives makes the problem easier is, do you remember what happens to the power every time you take a derivative? What happens to that exponent? It goes down, like it makes the problem simpler. So that's why this is a beneficial thing. Like, why would you take a derivative? Well, every time you take a derivative, you go down a degree, and then that makes the problem easier. So what is the derivative of just the numerator? So 2x minus 4, and then the denominator 2x plus 3. And now you can plug in 1 and get your answer. This was a little shaky before, so let's try again. If you plug in 1 to the numerator, what are you going to get? Good, -2. And if you plug in 1 to the denominator, 5. And that's your answer. Now for the rest of these, we're just going to do the problem. Okay? Not have to write out all the rest of the stuff. So for this one, we're going to write equals limit as x goes to 0. And then we're going to do the derivatives. So what is your derivative of e to the 5x? It's, yeah, e to the 5x, chain on a 5, okay? So 5e to the 5x. It's a chain rule, not a power rule. What happens to the -1? Yeah, that is gone. It goes away. Denominator, what's the derivative of just x? 1. Isn't that great? See, it makes the problem easier. And then we're going to plug in 0, and whatever we get is our answer. So e to the 0 power is 1. Good, times 5. 5 over 1 is just 5. Isn't that nice? It's a good rule. But do you guys get why I couldn't teach this back in limits? You had to be able to take a derivative. So like we had to do that. All right. So equals limit x goes to 0. All right. If you memorize the derivative of square root, it will make your life so much easier. So what is the derivative of square root? Good. Now it's of that stuff. So it's going to be 1 over 2 square root of x plus 25. Now, technically, there's a chain rule, but what is the derivative of x plus 25? It's just 1. So you can write .1 if you want. I kind of recommend against that, though, because if you do that every time, you're going to have .1, .1, .1 next to everything, and it's going to get really cluttered, right? This -5, by, it's gone. Derivative of just x is 1. And again, that's why it makes the problem easier. It's going to simplify it. And then you're going to plug in 0. And this is why it's so important to write limit, so you remember what to do at the end. Plug in 0. 0 plus 25 is 25. Square root of 25. 5 times 2, 10. So 1 over 10. Over 1, which is not going to change it. Now, I made these ones infinity. Limit as x goes to infinity. We're going to do our derivatives. So what's your derivative of ln? 1 over x. Beautiful. And then the denominator is just 1. So let's see what you remember about infinity, right? It's hard to talk about infinity because we as human beings can't comprehend infinities. Like we're going to talk about something we really can't understand. But if you imagine plugging in the biggest number you can imagine, you get 1 trillionth. And so what does that go to? 0. Because if I handed you like 1 trillionth of a cookie, you would be like, gee, thanks, this is a crumb. It's like nothing, right? Now this one, you can't do L'Hopital's rule unless you get one of these, 0 over 0 or infinity over infinity, which means you have to have a fraction. So we're going to need to rewrite this problem so that there's a fraction. And we can do that. How could we rewrite it so that there's actually a denominator? Go ahead. Good. It'll be e to the x in the denominator because the negative exponent brings it down. The x just stays where it is. Then you can do L'Hopital's rule. So limit x goes to infinity, and we're going to take the derivatives. So derivative of just x is 1. Derivative of e to the x is e to the x. And you can't plug in infinity. That's not a thing. But imagine plugging in like the largest number you can. You, again, get 1 over like a very, very, very big number. I've had people even write like very big or very small, like on their test. Anyway, it's going to go to 0. And I forgot to type an example like this, so I'm going to do a number 6. You'll all be okay.
That's where it was supposed to be.
So if you could just handwrite that one. All right, so we're going to go and take our derivatives. So limit as x goes to 0. You have to write that. All right, derivatives. So what is your derivative of x squared? 2x. Good. Then down here, the 1 is a constant. I'm going to just cover it up. We're left with negative cosine. What's your derivative of cosine? Okay, so it's negative sine of x. So good. Positive sine of x. Now, if you go to plug in 0, and this is why I made up this example, the numerator is 0 and sine of 0 is, sine of 0 is, think about the graph, guys. Where does the wave start? 0. So we got 0 over 0 again, which means we're going to do the rule again. And that happens. Sometimes you have to do it twice. I've never seen one that you had to do 3 times, but I guess in theory, if you kept getting 0 over 0, you could just keep doing more derivatives. You eventually get the power down to where it's manageable. All right, so derivative of 2x is 2. Derivative of sine is cosine. And now try to plug in 0 again. So 2 over 1, which is just 2. So again, sometimes you have to do it twice in order to make it work. Okay. So do you remember the definitions of a derivative? There were 2 of them. And after we get to the derivative rules, everybody's like, why on earth did you make us do that whole horrible process? And I'm like, I have an answer, but I have to get through the rest of this unit in order to explain it to you. Today's that day. All right. And again, usually if I wait long enough, someone comes up with it. There were 2 definitions for the derivative. One was the in general one, f prime of x. The other was the derivative at a specific number. Yeah, and don't come up here unless what is on your board. There's going to be limits. So the first one was what? Limit as what goes, h goes to 0. Very good. This will be a team effort. We'll just all collaborate until we figure it out. Good. Think of it like steps. F of x plus h minus f of x over h. Good. Well remembered. The other one also has a limit. It's this one, there's no h in this one because we just use x. X goes to c, and again, c would be a number. So limit is x goes to 3, or limit is x goes to 47. Bless you. This one looks a lot like a slope. What is on the numerator? Good. F of x minus f of c is c. Good. It looks like a rate of change, which it is. Instantaneous rate of change. So when you see problems like this on the AP exam, and did you catch that? When you see problems like this on the AP exam, because you will, don't freak out. I get that it looks horrible. You don't want to do it as a limit. Instead, you want to go, this means derivative, and do it as a derivative instead, because that is a whole lot easier. So here's the steps. You figure out what is the function that they're talking about. You take the derivative, which will be a real easy one, and then you figure out what number they want you to evaluate it at. And you're going to think it's 0, but it's not, okay? So looking at the first one, any guess that you just want to kind of figure out what the pattern is, like look for a function in there. What do you think the function is? I'm obviously going to tell you, but I just want to start by asking, like, look kind of just at this first part. Well, there's a 2, so it's going to be 2. I'll just go ahead and give you that one. It's 2x cubed. 2x cubed. It's 2 something cubed. You'll get the hang of it. All right, now what's the derivative of 2x cubed? Good. And then what is the number they want you to plug in? And you're going to think it's 0, but it isn't. 5. So let's plug in 5. So 5 squared, you're all going like, oh, I love when that happens. 5 squared is 25 times 6 is 150, and that's your answer. Let's try another one together. You want to figure out what's the function, take the derivative, and then what's the number they're asking you to plug in. Now this one uses delta x instead of h. I threw one of those at you back in unit 1 just so you could, sometimes they'll do that instead of h. If you don't remember, that's okay, but just pretend the delta x is an h. Don't worry about it. So what do you think is the function? It is 4x cubed, good. And then what's the derivative of that? 12x squared. This is cool because you guys are all like getting ahead of me, but let's stay together for at least one more. What's the number we're plugging in? 3. 3 squared is 9 times 12 is 108. I want to also do number 10 together. If you could slide down to number 10, and then I'm gonna like shut my mouth and let you guys try these. But there's trig in that one, so I figured we would just do that one together. Oh, sorry, it was 108. 3 squared is 9. 9 times 12 is 108, right? I'm not crazy. Okay. Yeah. All right, so for number 10, what do you think is the function? Yeah, you don't want to overthink it too much, like sine x. So derivative of sine is cosine. And then what's the number we're plugging in?
Pi over 2.
Pi over 2. Good. On your unit circle, where is pi over 2? It's at the top. It's the point 0, 1. Cosine is what part of that? X, which is 0. Perfect. All right, so here's what I'm going to do. I am going to just give you a few minutes. I want you to try the other ones, and then we'll go over them together. I'm going to start writing up the answers so you guys can check them, because walking around this is going well, and so I don't want to talk at you more than necessary. But can you guys just like look up here and check your answers? Like just make sure that they're correct and fix them if they're not. And if you think I made a mistake, please let me know, because I'm a human being and I make mistakes too.
Okay, well, I think the function is 2x minus 2. The function is 2 over x. Or 2x. Well, yeah, that's what I did. And I did minus.
Hey guys, can you check the ones I wrote up, 3, 4, and 5, and just tell me if you agree, disagree, or.
I agree.
Good. Okay, then let's look at 6 and 7 together. I liked the suggestion for this one to just do L'Hopital's rule. So write limit, and then what's the derivative of the numerator? 2x, derivative of the denominator, 1, and then you plug in 2. 2 times 2 is 4. I would actually do L'Hopital's rule for this one too. Now that I had that suggestion in my brain, I'm like, hey, that's going to be an easier way to do it. So write limit. What's the derivative of the numerator? 3x squared plus 1, good. Denominator would just be 1. And then you just plug in 3. So 3 squared is 9, times 3 is 27, plus 1 is 28. It should be. All right, now this one, I would go back to doing it the way that I had done the other ones. Find the function, take the derivative, and then figure out what you're going to plug in. So what's the function, do you think, for this one? Good. I mean, let me get everybody else there. It's 2 over x, which is 2x to the negative 1. I'm going to hold on. Are we all together? here on the same problem?
On the same.
Okay, do you get why it's two x to the negative one?
Yeah.
Okay, so when you take that derivative, you multiply the negative one down, it's gonna be negative two x to the power good, gets more negative, and it's negative two over x squared. Lots of negatives there, but you guys all passed algebra too, so gotta get through it. Now, I don't like the third step on this one. I feel like they should have given an actual number. What are they asking you to plug in? T, which is just like, okay, so instead of negative two over x squared, it's gonna be negative two over t squared, which is just kind of like, what are we doing here? I feel-
Extra step for no reason.
Exactly, it's an extra step for no reason. Like, they didn't give you an actual number to plug in. But anyway, yeah, it just changes the variable. All right, and then last one. What is the function for number 9? X cubed, yeah, you kind of need to not overthink these too much. Like, just look at it and use your common sense. What does it say there, you know? So your derivative is 3x squared. And this again is really kind of foolish because they're asking you to plug in p. So 3p squared instead of an actual number, they just had you change the variable.